thanks for braving the escalators coming all the way down here. I'm going to talk about Blueprint, a configuration management software that in many ways is analogous to tools like Puppet and Chef, but I think the focus that I've given it on a good development workflow over operational abstractions is going to be tempting to a lot of you. So, hi, my name is Richard Crowley. I work for DevStructure, which is the company that produces and works on Blueprint, as well as is building some cloud services and other non-free things surrounding Blueprint. The tool itself is written in Python, and hold your booze, there's no reason to write any Python to use Blueprint. It's implemented in Python purely because that language is available on basically every Linux system, and that makes it really easy. It's BSD licensed, and it runs on Debian and RPM-based Linux distributions, which is to say that it doesn't really do anything useful on Mac OS X. And there's a very good reason for that, which we'll get to in just a couple of slides. So the point of Blueprint, the workflow that it allows you to get into is that you work on your application and add dependencies and configure your development environment as you please. And Blueprint's job is to come around and figure out what you did to the server, store it locally in a JSON format in a local Git repository, generate code from it so that you can send it to your neighbor over at the next desk, and be able to deploy from it. And the origins of this tool are kind of entwined with what now is known as the DevOps movement. So I wanted to start by talking through some of the philosophies that made Blueprint the way it is today. And the first of those is, I believe in realistic development environments. And for everyone here, I'm willing to bet, that means Linux, because your production environment is going to be running on Linux. And in addition to using that same operating system in development, I think it's important to use the same sorts of web servers and database servers that you use in production. There's no other way to get a good feeling for the robustness and the quirky failure scenarios that you're going to come across in production if you're not exercising the same stack in development every single day. Following closely from that, I think it's great to be able to use interactive tools like apt-get or gem install to manipulate how your development environment is configured. As a counterexample to how easy and great that is, think about if you were using Puppet or Chef, where there's a configuration language off to the side. So to add a dependency that you're going to need immediately while you're developing your app, you have to switch to a different code base and find the correct place to put your new Puppet resource, and then test it and check the syntax and then run it and check it in. And then you can come back to an application code base where now you can use that dependency you just added. So the context switching overhead is just way too high, and I think that makes a lot of developers hostile towards those tools right from the get-go. Now, configuration management in general, this is nothing special to Blueprint, preaches the notion of managing the entire stack's configuration. And so this means not just your Ruby gems and the particular versions of those, but also the system packages that they depend on and other tools that you need. This means the configuration files for those services, like you'd store in Etsy. This means software that you've installed from source. This means the databases and everything. And a tool like Ruby Gems, for all of its strengths, is not by itself capable of handling this. Ruby Gems, and not to pick on it, every language level package manager has chosen a wide compatibility, for example, with Windows, but also with both Debian and RPM-based Linux and Mac OS X and everything else. So we need a kind of meta dependency declarations to understand the relationship between a set of Ruby gems and the underlying system packages that make them work. This is where Blueprint comes in. Another thing that basically every config management nerd would tell you is that it's important for everything to be idempotent. And this frees you up to run the command over and over again. No one's scared to run Puppet or Chef twice in a row and expect anything bad to happen. And likewise, you can run Blueprint over and over again without fear that anything bad's going to happen. And the reason for this, and the important characteristic, is that when we're dealing with commands like installing packages, we're dealing with commands that are already idempotent, that if things are already in the correct state, nothing's going to change. When we're dealing with placing files on the file system, we're checking and making sure we're placing the entire file's contents and never diffing or appending lines, because the first thing that happens when you start applying patches potentially over and over again or appending lines is that you end up appending the same line to your config file bajillions of times. You fill up your disk, everything's broken, nobody's happy. So having a notion of idempotence means that when you run the config over and over again, you're always going to arrive at the same desired state. So when you run over and over again, you can bring nodes into compliance, which is the buzzword that a lot of enterprise config management people use. The point here is that you won't have the fear at 3 in the morning when you try to run your blueprint over again to make sure everything's correct. Now, as we've developed Blueprint, we've come across a lot of decisions where we could do things in a bit more invasive or custom or unique way, or we could do things the UNIX way, the Debian way, or the Red Hat way. And we try to always choose doing things the most standard and conventional way to become the least surprising tool that we possibly can be. So when faced with where we look for configuration files, for example, we limit our search to Etsy because that's where config files belong on Unix. So this means that the tool's a lot simpler to understand. It's a lot simpler to predict what it's going to do, and this means that you can use it without fear that it's going to do something crazy. With apologies to a guy named Ryan Tomeko from GitHub, Blueprint means never having to say you're sorry. And he said this about Git, but I think the same sort of thing applies. There's never a case where installing Blueprint a month ago instead of 5 minutes ago will make any difference. So there's never a case where I have to say to someone, you should have installed Blueprint last month before you cowboyed the hell out of that server. Because the way Blueprint works is it's taking an absolute look at the state of the system, not a diff between what it is now and what it was last month. So no matter what you've done and no matter what order you've done it in, we can find out exactly how a server works and reduce it to kind of the minimal state that's necessary to bring it back on another server to do the same thing. So now for a short bit of history. When Blueprint and really DevStructure, the company, was first created, we were building a development environment that we intended to sell as a service. And this was a bad, terrible idea. And the worst of it was that the data that Blueprint was pulling out of systems was being stored in a relational database, which seemed awesome at the time, but it was actually terrible. Now, all of the data that Blueprint extracts from a server is stored in a JSON format that is well documented and easy to generate and consume. And when necessary, we use tarballs to store binary data and the like. So no more relational databases, no more secret cloud services that are holding onto your data without any ability to get it out. It's all very simple, and it's all stored locally. And of course, it's documented. And I believe that Unix man pages are the greatest documentation ever. So everything has a man page. The commands, and this documents what options they take and what they mean, but also that file format I was talking about. And if Chrome hadn't crashed on me, I'd show you the man pages. But imagine and go to the internet and see them. And what you'll find in the description of the JSON format is that it also describes the algorithm that you should use to apply it. So that if you're working from the same blueprint, two people's implementation of applying that to a server should work out exactly the same way. Again, it gives you the confidence to do it over and over again without worrying about bad things happening. And now the very last bit of philosophy is that I believe in a crowded market that I'm admittedly kind of a latecomer to, like config management, it's important for tools to interoperate well. And so in a bit, we'll see how Blueprint plays nicely with both Puppet and Chef. And kind of a different sort of interoperability is I believe that the tools we use should take full advantage of the production platforms on which they're deployed. So EC2 being kind of the Cadillac of that world right now, will show how Blueprint integrates tightly with EC2. So philosophy done. Now we can talk about the workflow that Blueprint promotes, which I think is the coolest part of it, and I think I've said that at least twice now already. So I'd like to walk through how Blueprint works, how you would use it, and what it does behind the scenes while you're using it. So since we're now all totally believing my philosophy, we're all starting with a Linux VM in Vagrant or VirtualBox or in the cloud or in the kitchen, and it doesn't matter where it comes from or what flavor it is. The important thing is that you have root access and that you use it. And so this means that when I get a new VM, the first thing I do is install Blueprint. This doesn't matter if you can read it. It sets up a Debian archive and it installs Blueprint. That's the first thing I do, and it's installed system-wide, and it's going to be able to appear in a Blueprint later in a weird kind of self-hosting way. Next thing you might want to do with your root access is install some gems. I support this. System-wide installation means that you have a consistent and understandable representation of what it is to be that type of system. Less awesome is if you use a tool like Bundler, for example, to pick on one, to install gems off in their own directory someplace that's not well known to the system and can't be introspected reliably. So given that Bundler's basically a requirement for Rails, install things system-wide, and then you've got a complete picture of your dependencies in a discoverable location. Now, likewise with gems as Ruby itself, tools like RVM and RBEnv have gained a lot of popularity, I think mostly because of OS X. But once you get to the place where you're developing in a Linux VM, there's, I don't think, any reason not to install Ruby system-wide and the version of Ruby that you actually want. And I'd encourage you to look into a tool. Yeah?
Were there arguments I've heard against installing your production system-wide is that some distributions use Ruby for their own purposes. You might screw them.
He said that some distributions use Ruby for their own means, and you might mess that up, which is very true. And it's not so much the location of the files, so it's not that it be user bin Ruby, it's that it be in the apt or yum database for you to audit and upgrade and remove that reliably. And so here's Josh Timberman from OpsCode wrote a little quick thing that uses FPM, Jordan Sissel's package management tool, to build a Debian package for Ruby 192 whatever. And this is, like I said, auditable, upgradable, downgradable, uninstallable, and if you run your own Debian archive, then you can do this for much more than just Ruby itself. You can do this for any particular system dependency you have that you need to deploy outside of the confines of whatever Debian or Red Hat gives you. So now that you've got a bunch of stuff on your server and it's all installed system-wide, we can create a blueprint. And so you can imagine you might run blueprint create and give it a name. We'll call it foo. This is what kicks off the reverse engineering of the server. This is where the magic happens, I suppose. And it goes through a lot of backends figuring out what to do, and prints a little status along the way. So let's talk about what it does at each of these steps. So the first thing it looks at are packages in a whole bunch of different package managers. The system package managers like apt and yum will, in addition to grabbing the full list of all the packages installed and their version numbers, it will take a hard look at those systems and figure out a representation of the base system, the packages that can be ignored because without them you don't even have a functioning Linux server. So packages marked essential in Debian and packages descending from the yum group called core in Red Hat world, and there's some others too, are taken out of the blueprint so that they don't clutter things up. We're reducing noise and at the same time kind of increasing the strength of the statement that including a package in the blueprint gives. If we list every package, then it's just these are the packages on the system. But if we start to remove stuff that's considered common or trivial, then the blueprint becomes a representation of what's special about your system. And that means that it's smaller and easier to read and more personal to how your environment works. So all these other package managers work roughly the same way, grabbing names and versions and storing them in the JSON format for later. The next sort of resource that we look for are files, unsurprisingly. They're configuration files for the various packages and services that you've got, and by convention, those are stored in Etsy. So we only look in Etsy, and this simplifies the process for Blueprint and causes it to be a lot more reliable in picking the correct files. Again, we try to ignore a lot of things, like files that are included in a package and haven't been changed from that package, as well as a lot of other heuristics about files that are placed by the post-install script from a package, which is a terrible thing. Don't do that. And we have some other dirtier heuristics with ctimes and some packages in Debian that don't actually include checksums for their files. So we do a lot of work to reduce the number of files we include down to just the bare minimum things that are different and special about your system. So now another form of resource that we track we call source installs, which is admittedly a little bit of an ambiguous and terrible name. But this feature was invented to handle and allow people to configure, make, install on their systems and have that still become part of the Blueprint. So by convention, again, those things go into user local. And so we only look in user local by default. And this gives you a place to install binary files or custom scripts of your own, or even your entire application. And whatever you put in user local, we're going to store as a tarball alongside the Blueprint, so you've got potentially your entire application ready to deploy via a Blueprint. And now the last type of resource that Blueprint takes a look at are services. And these are definitely a little bit different than everything else, because if you'll notice, everything so far has been file system state. It's been one or more files on disk, their metadata, et cetera. Whereas a service is a running process. It's runtime state and not something that we can describe in the same way. So one possibility would be to describe a service by its file that determines how it started and stopped, but that's in etsyinit or etsyinit.d, so that's already a file resource. So what we actually care about for a service resource is the conditions under which it should be restarted. And this means that we pay attention to things like if a service definition mentions another file or another directory, we restart the service when those files and directories are changed. If a service definition is the member of a package and that package is upgraded, we restart the service. So this means that when you apply a Blueprint, you're going to get not only the latest updates to your disk, but you're also going to have that reflected in the runtime state of the system. So that gives us more like a full deployment system baked into Blueprint. So remember long ago when this was all the process of running Blueprint create? It actually takes about 5 seconds, so that was very long-winded in comparison. But once you've got that, once it's run, it's stored locally in Git, and you might be tempted, and rightfully so, to inspect what's in the Blueprint. So this Blueprint show command would tell you in the JSON format what's in the Blueprint. And so you can see, without really needing to read, there's a file, a package, and a service defined here. And they define metadata and versions, and you can real quickly inspect that and see what's in it and what's not in it. Likewise, another Blueprint, this one that has the systems Ruby, some gems, and then a source tarball that we've extracted from user local. And again, you can see quickly what's in it and what's not in it, and be able to understand if something's missing, and we'll get to how you correct that in one moment. If the looking at raw JSON gives you a headache, you can use the kind of shell-friendly front ends to that. Blueprint show packages is one that prints the package manager, name, and version all in a pipeline-friendly format that you can send through grep and set and awk and do strange and wonderful things to it. Likewise, there's Blueprint show sources. There's also show files and show services. And the sources prints the verbose listing as if from tar TV, so you can see what's in those tarballs. And you may find, after looking at your Blueprint one of many possible ways, that you don't like it, that there's something missing, there's something that's too verbose that you installed a month ago and you don't actually care about. And inspired basically exactly by gitignore, we've got an answer to that in the form of the blueprint ignore file. So a file something like this in your home directory would tweak how Blueprint determines what files to include, what packages to include. So the top section looks exactly like a gitignore file. It follows all the same rules. It ignores directories and files, and it unignores things with the exclamation point in the beginning. Yeah?
Is the blueprint ignore file included in the blueprint itself then?
Is the blueprint ignore file included in the blueprint? Not in the same way that another file is, but yes, it is stored with each revision of the blueprint. So you can, a second ago you could say blueprint show packages. You can say blueprint show ignore and get the ignore rules for that particular blueprint. So the second section is where we introduce new syntax. Colon, resource type, colon, so to ignore or unignore packages. And likewise at the bottom, source directories, we can ignore the very bottom. We've unignored the opt directory so that we're now creating a tarball of whatever's in opt, and we can deploy whatever we have in opt that way as well. There's a curious, strange pattern in the middle here where we ignore and then immediately unignore the build essential package, and I feel like this deserves explaining because it looks kind of strange. When I worked on this feature at first, we took a long look at what the least surprising behavior would be. And when you ignore a package, the least surprising thing seems to be to also ignore all of its dependencies. Whereas when you unignore a package, the least surprising thing is to only unignore that one package. So the behavior that emerged is that if you ignore and then unignore the same package, you end up only ignoring its dependencies, which is a cosmetic but not functional impact on what actually happens when the blueprint is applied later. This just removes the 20-odd dependencies of build essential from the blueprint, but makes sure that they'll still be there in the end. So now with this, we run blueprint create again, and we've got a blueprint we're real happy with. And now you might want to share it with somebody else, another developer or the new hire, perhaps. And so you can use a free service that we're offering experimentally where you can push it to the cloud and pull it back down on some other service. So you run blueprint push, and it gives you this nasty long URL that identifies your blueprint uniquely in the cloud, and someone else can use that URL to pull it back down. And we store them behind really long, unguessable random URLs so that there's no need for user accounts in such a simple service. And we store them in S3 because that's cheap and easy and reliable, and we don't have to convince anybody that may not trust us that the data is going to be there. So when the new guy pulls that down, he's got this blueprint stored locally in his Git repository, and with blueprint apply foo, he's able to bring that new dev box that's brand new up to the same state as the one where the blueprint was created a minute ago. So now with 2 commands, the new hire's up and running and writing code, and that's great. But it doesn't get you all the way to production, which is, of course, where everybody wants to be, right? You could use that same pattern of pushing and then pulling and then applying on your production servers, but that would mean that you have to have Blueprint installed, which is not a big deal, but for some folks that may mean something. And it's a little bit primitive, and it's something that we can do better with, so we do. So the first and the easiest thing that we can do better is by using blueprint show and giving it the -S argument this time. And this, instead of printing a bunch of JSON to the screen, which is nearly useless, we create a shell script that will apply all of the resources identified in that blueprint, one after the other, following the algorithmic order, and doing so in a safe, idempotent way. So you could take foo.sh and immediately send it to production and run it, or you could give it to your version control system and maybe your CI system to walk it through the staging process and make sure everything works fine there before pushing it to production. But now you don't have to worry about carting the whole of Blueprint along with it. Blueprint can remain a development-only tool. And the code it generates looks something like this. And I mentioned that it follows the algorithm and that it does so in a nice idempotent way. So you can see that it's gating the installation of a package by checking the version that's available, so we don't waste time in apt if it's ultimately going to decide everything's fine. And then when that package is upgraded, it notes to restart the SSH service, which it does on the very last line there if it needs to. So that's cool, right? Idempotent shell scripts without having to think about it. This is the part where if you're a Puppet or Chef shop already, you can use Puppet and Chef still in production, but use Blueprint in development. And the end result here is that you get the great workflow, yet your operators are still happy that there's Puppet and Chef code. So the Puppet code looks something like this. It's pretty much human readable. It follows the coding standards, and it provides a lot of hooks to be able to grab just the subset of functionality you want, should that become necessary. And again, it follows the algorithm for applying a blueprint by declaring the order of dependencies along the way. Here is the generated Chef code, which is actually in Ruby, a special API given to Chef recipes. And likewise, applying those same three resources, it follows the coding standards and it performs them in the algorithmic order. And if you gave this to your operators or your guy in charge of Chef or Puppet, he really wouldn't know the difference between this and human-written stuff. Yes?
Can you give us some reasons why you believe that your format is, or some advantages that they have over Chef and Puppet?
It's about the development workflow, not about the particular text format or anything like that. So it's about the fact that you, a developer, don't have to ask operations or deal directly with Puppet or Chef code to make changes to how the environment works. So there is the generated Chef code. It's awesome because it looks like a human wrote it and a machine did. If you're not already using Puppet or Chef, though, I'd encourage you to think about using Blueprint through and through. And one real cool thing we can do is, since there's a cloud service where you can push and pull blueprints, we have an API endpoint there that can generate shellcode for the blueprint remotely, which means you can download it, analogous to a blueprint pull. You can download the shellcode from the server directly and not have to install Blueprint. So you can do like this, and I apologize for the tiny font. You can set a cron tab up to download the shellcode for your blueprint directly and pipe it to shell. So with one cron tab, you've reinvented the hourly compliance run that Puppet and Chef run daemons for, just right there. And this means that when your definition of what it is to be a web server or a database server or an app or whatever else changes, everybody brings themselves into compliance automatically as that definition is pushed. And the last thing that we do that I think is especially cool is interacting with EC2 and providing this sort of shim to allow straight EC2 users or CloudFormation users to immediately bootstrap new servers with a given blueprint. And so instead of the foo.sh endpoint from a moment ago, if you grab userdata.sh, you get this little shim that at first boot will launch, download and launch the blueprint of your choice to configure a server and make it ready to go. Yeah?
If you change your configuration and no longer need certain packages, will it actually uninstall those packages?
It does not currently do that. It's something I'm interested in adding, however.
So there is this minor, it probably doesn't affect your app, but if there's a minor lack of idempotency there, right?
Yes. Let's see. In a system where if you're uninstalling system packages or you're adding, especially downgrading a Ruby gem, since you can have multiple versions of Ruby gems, those are the two cases where it could bite you. In practice, that doesn't tend to happen because people tend to upgrade Ruby gems, and people tend to just not rely. If system package should be uninstalled. They tend to just not rely on it anymore. So it hasn't come up, but it's something that I would like to make better. And that's one good piece of future work. The others that I'm thinking about are bringing some notion of modularity to the blueprints so that your common functionality across all your types of servers can be in one blueprint, and the extra special things that make each server unique can be in their own blueprints. And in addition to that, we're always adding new resource types, new service providers, new package providers. So if you've got features we're not supporting yet, please submit bugs and tell us about it. And that's all. So if there are more questions, bring them on. Yes?
I understand why you don't concentrate on Mac OS X. I completely understand why. But I'm just curious if you could get it to work if working with someone like Backports or Homebrew and standard tools like that.
So you caught me in a little bit of a lie. It'll totally work on OS X, and if we built a package provider for Homebrew, we would be able to extract that information very easily. The problem is nobody's deploying to OS X, so there's not, we'd have to maintain a mapping of what the Homebrew package name actually means in Debian or Red Hat. And that's the hard part. And, it's manual labor that we don't have the resources to do. Anybody else? Yes?
You seem to think that perhaps the developers know more about how to run the operational environment than the operations people. At least that was sort of what I got from your comment. I kind of take exception to that.
There's some of that that's true, and there's some of that that's not. I think it needs to be a pretty collaborative process, and the part that I think is most of a bottleneck is the evolution, not the, and I guess this is the classic argument, the operators want stability so nothing can change, the developers want everything to change because they want new features. And the middle ground is a place where a developer can add a dependency in a real documented, understandable way, say by pushing a new version of a blueprint, and an operator can understand and perhaps even reply with their own revisions to the blueprint how that change should have been implemented, can be implemented better, or clean up the mess necessary to actually make it work. Yes?
So you showed us like how when you first start a system, you're going to install a blueprint on it, and this is, I guess, how you're going to set up a blueprint for future systems. But can you talk a little bit about after you've got your blueprint, how can you automate the rapid deployment of these and like bringing them up and down at will, or in response to like changes in load and things like that?
So part of the process of provisioning one on a new server would be knowing the host name or IP address and what blueprint should be applied. And it's definitely outside of the scope of blueprint itself to be kind of an auto-scaling feedback loop. But either through the pushing the Git repository that blueprint keeps all of its data in to, say, your CI server or your build server, or using the push and pull service directly. One of those will give you the raw material to configure a new box, and then it's a matter of using either the shell download or blueprint show-s to generate the code that can bring up a new server with the correct configuration. But the feedback loop is something people implement hundreds of different ways outside the scope of config management. Yep.
I guess the reason why I ask is because Puppet sort of, I mean, I only started to work with it, but my understanding is that it's sort of, with the Puppet server, it has some of the aspects of bootstrapping new nodes or new servers a little bit built into it.
Well, with the exception of getting Puppet on those nodes, that's pretty much correct. They're headed to a world where you have a pool of unallocated servers, and Puppet can pick one with the appropriate specs to fill a role as needed. And that's been the real long-term goal of Puppet, and they're just now getting to the point where that's feasible. And even then, only on EC2 so far. Anyone else? Looks like a no. Thanks, guys.